morning all. So today we are going to discuss about the second part of this micro network analysis, that is called micro passive devices. So now basically scattering parameters, how these scattering parameters are utilized, how to decompose it, and how these scattering parameters, this property helps us to analyze the particular device. And with the help of signal flow graph, we have identified that the complex derivation can be solved within a few steps using the signal flow graph technique. Now whatever the thing we have discussed in the last class, it is with respect to the fundamental knowledge of the scattering parameter and usage of scattering parameter and the signal flow graph for a particular device in a particular situation, whether the input port is input port is provided with a source and output port is terminated with a load. If the load is terminated with match condition, if it is a short circuit, if it is open circuit, then what are the conditions we are going to identify. Those things we have studied. Now today we are going to discuss about the devices. Now the scattering parameters, whenever we are discussing about the microwave device, means the scattering parameters will come into picture. So depend upon the nature of the scattering parameter, we have to judge the particular device. That also we can do. Okay. So if it is a 3-port network, if it is a 4-port device, if it is a 2-port device, whatever it is, the scattering parameter speaks that which sort of device it is, whether it is a power divider, whether it is a power combiner, whether it is a power splitter, whatever it is. Okay. So we will discuss today about more about the T junction. Okay. T junction means these are called as waveguide T's. Waveguide T's. Now these waveguide T's are basically different type of T networks are there. This is called T junction. This T indicates that it is a T junction. T junction will be there. So T junction network means the representation will be in the form of T. So this T is depend upon the waves. We have to judge the working principle of the T junction depend upon the nature of whatever the input wave is provided. Okay. Now since it is a waveguide, means it is a device. These waveguides are basically represented either in a cylindrical manner or it is in a rectangular manner. Today we will discuss with respect to the rectangular devices. Okay. And in these waveguides, the waves are going to propagate. Which sort of waves? It is electromagnetic waves. Now if this waveguide only conduct the electric field, that means this particular device only respond to the electric field and magnetic field suppression will be there. Similarly, if you want to communicate with respect to magnetic field, suppressing the electric field like transverse electric mode, transverse magnetic mode, and our TEM mode is also available. So depend upon the nature of wave which is propagating, we have to judge and we have to identify the S parameter with respect to that particular device. So this waveguide T's basically represented either in terms of E plane T, okay, or H plane T junction. Okay. So this E plane T, this is called series T, and H plane T is called as parallel T. Okay. Now why it is series, why it is parallel? Question comes. So series means, since electric field is related with respect to the potential and the potential varies with respect to the series combination. If there is a series combination of a network is there, potential will vary, due to which electric field is also going to vary. But when you consider the potential is same, that means it must be in a parallel form. That means in that case we will use this H plane. Why? Parallel combination, potential is same, current is different. So if the current is different, magnetic field is also going to be different. So like this we have to analyze it. So these are the basic representation. If I will combine this H and E combinedly, then it becomes a hybrid T junction, in which both electric field and both magnetic field are going to play for a certain time period. Okay. With the help of that, either we can combine, either we can distribute. Okay. So here this E plane is basically used to divide the power. we will see how it is divided, what are the parameters are there, how we can analyze it, how it can be combined and all. Okay, so basically this E plane T is basically used to subtract the potential, subtract the powers. Suppose if it is a 3-port device or 4, as the T junction is a 3-port device, here you can see this is port 1, this is port 2 and this is port 3. So if the power is fed at port 1 and 2, the output power means in the port 1 and port 2, if I will feed the power P2 and P1, then port 3 will have P1 minus P2, means subtractive arm, means subtractive potential can be identified. Similarly, in H plane T, in this the potential can be added. Okay, we will see how this particular principle will work. Okay, so for the time being, the E plane T is basically used to subtract the power, and for H plane T is basically used to combine the power. Means it is basically used as a divider, and power division will be there, and here power combiner will be there, because whenever we are dealing with a microwave network, we require this sort of devices. This sort of devices means sometimes the power need to be distributed to some other part. So who will distribute that? Some devices must be used. Some arrangement must be done so that power can be divided from one port to the another port. Okay, so in between that we have to identify the relations, and with the help of this waveguide T's, we have to analyze that electric field. When we are going to identify, if we are using the electric field analysis, then what will be the size of waveguide? If we are using for the H plane T, then what will be the size of waveguide? And how these waveguides are going to propagate, and how this going helps the waves to propagate, whether it is combining or whether it is subtracting. Okay. Okay. So here few points have written regarding the waveguide T's. Let me discuss first. So here you can see these are the 3-port device. As I have told, this waveguide T's, T itself indicates that it is having 3 ports. Okay, port 1, port 2, port 3. Now this arrangement is done as per the representation of electric field and with respect to the magnetic field. Always remember that electric fields are moving radially outwards. Okay, and magnetic fields are circular in nature. So circular means it is in a lateral side. If it is a radially outward means it will be in a vertical manner with respect to the magnetic field. It must be perpendicular to each other. Okay. Now here I have drawn 2 figures. This is called E plane waveguide T, and this is called H plane waveguide T. Now why it is H plane? H plane means here the potential is same. Means here the power combining will be there. When the power will be combining? When the network is in parallel. So current will be in parallel form, total current will be added up, and the power will be identified as V into I. Okay. So here the magnetic field is in a lateral manner, so it is the collinear arm. There are 2 basic arms will be there in that waveguide. One is the side arm and one is the collinear arm. And the electric field and magnetic field must be propagate according to the side arm direction, according to the axis. Okay. So first point is these are 3-port components. Yes, these are 3-port components. Okay. Second, used to connect the branch or a series, to split or to combine the power in between the microwave networks. Whenever we require our power division, or we have to split the power, we have to distribute the power, then we are using this sort of waveguide T's. Okay. Then third point is there are basically 2 types are there, but using these 2 types the hybrid can be formed with the combination of E and H plane both. So 2 types, one is E plane and one is H plane. As I have told, E plane is basically represented as terms of series. Okay, series T junction. Similarly, H plane T junction is represented with a parallel form. Parallel means it is a shunt form. Okay, and name according to the axis of the side arm, which is the parallel to the either electric field or the magnetic field of the collinear arm. So as you can see, if I will draw this network, E network, let me draw like this. So this is my series, just I have to upward. Okay. Now here the electric fields are moving like this, side arm. This is the side arm. Okay. So if the electric fields are provided here, that means the electric field will move in this particular direction and in this particular direction. These are the electric field, because power is fed in this particular port, due to which electric field, when it is entering, some electric field will move in this particular direction and some electric field move in this particular direction. Means power will be distributed either in this or in this particular part. You can see that electric field in both the cases, the directions are different. In this it is moving downward, but in this port it is moving upward. Magnitude will be quite similar, but it is out of phase. So here we can say that it is act as a distributor. Distributor means it will distribute the potential. When the potential is distributed, when the circuit is in series in connection. In series, the potential is going to be distributed. Here the electric field is distributing. Okay, so that logic we have to use. So this is used for the electric field, E plane T junction. We will draw once again this one, but for the time being I will represent this. Here power is fed at port 3. Let us consider this is port 3, this is port 1 and this is port 2. Let us consider. So here the electric field, when it is injected, it will distribute. Okay, one it will move towards port A and some part it will move toward port 2. So you can see that electric field is moving in this particular direction, is moving downward, direction is downward, but in this case after reflection it is moving upward. So here this reflection happens and it is moving upward direction. That means power whatever is available at port 2 is out of phase with respect to port 1. Now if it is out of phase, that means subtraction is there. If it is in same phase, then we have to add these two components. So when it is in same phase, we have to add it is in this shunt series shunt T junction. Okay. Now this is the representation of a E plane. There are the base is there, means suppose this is the base. Okay. This is the waveguide. This is port 1. This is port 2, and 1 minute. Let me take this showcase, means this my eyeglass case. If it is look like this, if college opens, I will show that waveguide how it is look like. So if the base is like this and there is a side arm is vertically placed like this. Okay. Now whenever this junction is represented in this form, this particular port is called as port 3, this particular port is called as port 1, and this is port 2. So whenever the power is fed at port 3, the power will split into port 1 and port 2, and that to be out of phase. Because the electric field direction is changed. One, it is in phase if you consider with respect to port 3, and another one is out of phase with respect to port 3. And here also you can see that 1 and 2 phase are little bit out of phase, means 90-degree phase shift will be there. So if your waveguide is like this, if the T junction is like this, upper part is having a certain length, this is our side arm, this is our collinear arm, these two are ports, and this is the third port. If it is look like this, then it is called electric field or E plane T junction. Okay, but say at the same time, if this side arm comes here, means if it is look like this, means the collinear arm, and in the collinear arm we have a side arm like this. Okay, so here you can see the collinear arm is the upper horizontal line and the vertical downward line is called as our this side arm. Then if it is look like this, okay, if it is look like this, that means here it is called as a H plane, it is called as a shunt. Okay, so here it is called as a shunt. In shunt your potential total potential will be same and current is distributed. If the current distribute, magnetic field is also going to distribute. Here we can combine the power. With the help of this we can combine the power. Means if I will provide the power at port 3 or if I will provide the power at port 2 and 1, the total power what it is available at 3, it will be added up. Suppose here it is 5 watt you are providing and here it is 10 watt you are providing. At port 3 we will get 15 watt. It is a power combiner. But at the same time, if I will use the this E plane T junction, if I will feed the power here 15 watt, moreover here we will get 10 watt and here we will get 5 watt. Like this, it is a power splitter and this is called as a power combiner. This all thing we will justify with respect to the scattering parameter. Okay, so these are the basics representation of E plane and H plane T junction. Okay, so always remember that E plane means it is a series T, H plane means it is called as a shunt T. Okay, shunt T means potential will be the same, current is distributed. Current distribute means your magnetic field is going to either combine or we can distribute it. Okay, in phase component. But at the same time, electric field means potential will change. Potential will change with respect to the series impedance. So here it is series in nature. Potential will change. Electric field is also going to change. Here you can see electric field is also going to change. We will solve all these things step by step with the help of that scattering parameter, and we can justify it and we can form the standard representation of scattering parameter for E plane T junction and H plane T junction with the help of this consideration. And one more important thing, these waveguides, these devices are poorly matched condition. Poorly matched means the port whatever it is available at port 1 and port 2, if you connect with the microwave devices, the impedance is not same. Impedance of the transmission line and of a particular waveguide, if I will connect here, this impedance are mismatch condition. If there is a mismatch, the scattering parameters will change. So for that you have to use a tuner. When we will set up a microwave test bench, in that tuner is also there. That tuner will help to match the impedance. Okay, that we will see later on. But for the time being, these networks are poorly matched condition. Means it cannot be matched perfectly. Some impedance will be there, some reflection coefficient will be there, mismatch conditions will be there. Okay, so we will analyze all these things step by step. First we will discuss with respect to E plane, then we will discuss with respect to H plane, and then we will solve few problems. Okay. Okay. So first we will discuss with E plane. Now as I have discussed with respect to E plane, the distribution will be there. Now this is the simple representation of E plane junction. Here what happens, power is fed at port 3, due to which the power with respect to 1 and 2, it will distribute. Okay. If it is distributing, we can say it is called as subtractive, because vice versa if I will take, if I will provide the power at the input at 1 and 2, this is our input and 2 is also input. So power is given at port 1 and 2, this is P1, okay, and this is P2. My P3 will have P1 minus P2. It is a subtractor. Okay. Why? Because it is in series. Series means potential will change. Difference potential will be available. Same thing, if power is fed at the port 3 like this, if power is fed at port 3, that means the output powers are available at port 1 and port 2. Okay. So P3, again if it is power is given, the total distribution will be unequal. Here it is some 10, here it is 5, here it will be 15. So like that you have to identify it. It will distribute it. This is the working principle of your E plane. But how to identify the S matrix for that? S matrix means scattering parameters, because as we have seen in our signal flow graph, that each port is represented with a node, with the incident and reflected points are there, and the relationship between port 1 and port 2 is identified with the scattering parameters. Okay. Now these scattering parameters are, one minute. These scattering parameters are identified with respect to the ports. Now here, how many ports are there? There are 3 ports are there. Port 1, port 2, port 3. So if there are 3 port network, how many scattering parameter must be there? There must be, scattering parameter must be 9. what will be S11, S12, S13, S21, S22, S23, then it is S31, S32 and S33. So there are 9 scattering parameters are there, and we have to identify the scattering parameters. Okay. For that we have to identify the particular ports which is excited and where the outputs are there and what is the linkage between them. So like that we have to identify first the assumption. According to that assumption, we have to identify the all scattering parameter. Okay. So first assumption is considering the symmetric and phase relationship of wave in each arc. Phase relationship means, as you can see, the port 1 phase and port 2 phase are 90-degree phase shift, means up and down. This is moving upward, but this is moving downward, 90-degree phase shift. But the magnitudes may be same, may not be same. Okay. Then second consideration is, let port 3 be the incident port, means at port 3 we are giving the input power. Then at port 1 and port 2 the power will be distributed. Same potential can be available, may not be same potential can be available. Let us consider same potential is available but opposite in phase. So what I have written, so port 1 and port 2 results power are equal in magnitude, okay, but opposite in phase. Equal in magnitude and opposite in phase means the magnitude will be same but phase will be 90-degree apart. If one value is 5 angle 0 volt, then another will be 5 minus 90-degree 0 volt. Like this we can assume. So this is the equal potential is available but out of phase. Okay. So this is only for the understanding I have written. Next, if this is the condition, then what will be my scattering parameter? That question comes. Okay. Now in this figure you can see that we are feeding the power at port 3. So power is related with respect to port 1. So power is related with respect to port 1 and 3, and power is related with respect to port 2 and 3. And one more relation is 1 and 2 is having the equal amplitude, means magnitude is same. Let it be. We are considering that one. So if S12 is equals to S21, so this is called as our symmetric condition. Ij, I is equals to 1, j is equals to 2, Sij is equals to Sji, that is called as our symmetric condition we have identified. Okay. So S12 is equals to S21, that is the first condition. Second, now the relationship with respect to port 3 and 1 is magnitude is same but the phase is different with respect to 3. So that means S13 is equals to S31. It satisfies the symmetric, yes, it satisfies. But if this with respect to 2, if we are measuring, that means the magnitude is same but opposite in phase. So what I will write, S13 is equals to S31, 3 with respect to 1, and the relation with respect to 2 is 90-degree phase shift. That means minus S23 is equals to minus S32. So this is the second condition. First condition is what? S12 is equals to S21. So here I have written S13 is equals to S31, which is related with respect to 2 and 3 is out of phase. You can see that out of phase is there, 90-degree phase shift. So it is minus S23 minus S32, that I have written here. And the port 1 and port 2 are symmetric, so S12 is equals to S21. But if it is related with respect to 3, phase will change. Okay. So this is the first condition and this is the second condition. Using these two conditions, one more important factor, as I have told, that the waveguide tees are poorly matched. If it is poorly matched, the diagonal elements, as you can see, S11, S22, S33, these all are diagonal elements. What it indicates? S11 is eta 1, S22 is eta 2, and S33 is eta 3. So these are the reflection coefficient. If it is perfectly matched, all these reflection coefficients are 0. But if it is poorly matched, the diagonal elements may not be 0. Okay. So that we have to take in consideration. So how to proceed, how to calculate it? The three things I have told. First, the device is symmetric in nature, yes, and it should satisfy the phase relation with respect to the waves. First, symmetric is what? Port 1 and port 2. So S12 is equals to S21. That is the first condition. Second, if we provide the power at port 3 will have a relation with port 1, port 3 will have a relation with port 2. But these two relations are having same magnitude but opposite in phase. Okay. So that I have written. For 3 and 1 it is S13 and S32. And for port 3 and 2 it is S23 and S32. So these are the two relations. Magnitudes will be same but opposite in phase. So what I have written? S13 is equals to S31, which is equals to minus S23 and minus S23. So this is the relation we have identified. One more relation is what? Since it is a poorly match condition for this 3-port network, the diagonal elements may not be 0. How to make 0? We have to assume, we have to identify in which particular port we are feeding the power. We have to perfectly match it so that maximum power can be injected to that particular port. Okay. So here I have written, due to the poorly matched diagonal elements cannot be 0. Due to poorly matched all the ports, due to which the diagonal elements are not 0. So this is one hint is given. These are the two hints. With the help of these two hints, we will proceed. How to determine the scattering parameters. So let me erase it, and once again I will write. So first condition is what? First condition is S12 is equals to S21. Second condition is 3 with respect to 1, 3 with respect to 2. So it is S13 is equals to S31 is equals to minus S23 is equals to minus S32. So this is the conditions. These are the conditions. Assumption we have took. Done. Then third assumption is all diagonal elements are not 0. So for that, what I will do, considering port 3 is perfectly matched, due to which maximum power will be injected in port 3. Okay. So for that I can write S33 is 0, because diagonal element S33 indicate what? Reflection coefficient. If it is perfectly matched, S33 is 0. So this is the third condition. So using this condition we have to identify. Now, where we are providing input power, fourth point, input power is provided at port 3. Port 3 we are providing the power. So when we are providing, we have incident power and reflected power. So what is the transmitted power? So here I will write, it is mod A3 square minus mod B3 square. So this is the input power. Done. So what I will do, I will take this A3 square common, 1 minus B3 by A3 whole square. Okay. So B3 by A3 is nothing but S33. So it is 1 minus S33 whole square. For the time being, this perfectly we are not considering. We will consider later on. But first we will identify this relation. So input power is provided. Done. Then output power at port 1 and port 2. So B1 square plus B2 square. Why I am considering B1, B2? Because here we are not energizing. Here it is only outgoing. So here it is, we are considering B1, Here we are considering B2. Done. So B1 square plus B2 square, I can write twice of magnitude of A3 square into S13 square. That means what I have done, I have divided and multiplied A3. So first one I will get B1 by A3 and B2 by A3. So B1 by A3 means S13 and B2 by A3 means S23. Both magnitudes are same. So it is twice of S13 square I have written. Now when it is a junction is lossless. Now here when the power is fed at this particular perfectly matched termination. Okay. So if it is perfectly matched, port 3 is perfectly matched. So here what happens? It is considered as a perfectly matched. S33 is equals to 0 and we are considering the junctions are lossless in nature. Okay. Here I will consider it is lossless. Okay. If it is lossless, that means whatever the input power we are giving, same output power we are achieving. Okay. So here I will write due to lossless junction at port 3, input power is equals to output power. Done. So what is our input power? Input power is mod A 3 whole square 1 minus S33 whole square is equals to twice mod A3 whole square and S13 square. Done. Why I have took as a input power is equals to output power? Due to the lossless junction. Okay. Next, A3 square cancelled out. S33 is 0 we have considered. So what I will have? Let me erase this. So if I will solve this relation here, I will get 1 is equals to twice of S13 square. So that means mod of S13 is equals to 1 by root 2. Now as we know that S13 is equals to S31. That is the first condition here. And S23 is equals to S32. Magnitudes are same but opposite in phase. So if I will write, therefore S13 is equals to S31 is equals to 1 by root 2, then S23 is equals to S32 will be minus 1 by root 2. So that means almost all parameters we have identified. Now we have to represent the scattering matrix. So S is equals to S11, S12, S13, it is S21, S22, S23, and here it is S31, S32 and S33. Okay. So what are the parameters we have identified? S33 is 0 due to the port was matched perfectly because we are feeding the power in it. So that means this S33 is tends to 0 over. Next, S13 we have identified 1 by root 2. S13 and S31 both are 1 by root 2. Okay. Then S23 and S32 is minus 1 by root 2 and S32 is also minus 1 by root 2. Okay. Done. Next, how many things are and S12 is equals to S21. This is the reciprocity theorem. Okay, symmetric condition. And other two factors S11 and S22 is also left. How to identify this? Let me derive it. Now we have, as we can say, it is a lossless junction, and the property of the lossless junction is the unitary property it must satisfy. If you see, if the row, if I will take this third row, okay, third row, row 3, mod of 1 by root 2 whole square plus mod of minus 1 by root 2 whole square plus 0, it must be equal to 1, lossless junction, and that is the unitary property must be satisfied. So if you solve this, you will get half plus 0, which is equals to 1. So it satisfies the lossless junction. Over. Next, what are the unknown factors are there? Unknown factors are S12, S22 and S23. So S23, S11, S12 is there. That means what should be the combination so that the square terms of those whole values must be equal to 1. So if I will take row 1, it is a hit and trial method, mod of S11 square plus S12 square and plus S13 square is equals to 1. It must be equal to 1. If you take this column third also, 1 by root 2 and 1 by root 2 square become 1 and resultant is 1. It satisfies. Now here unknown factor is mod S11 square, S12 square and S13 is already 1 by root 2. So 1 by root 2 mod whole square is 1 by 2. So it must be equal to 1. That means what should be the combination of this S11 and S12 square so that it will add with this half, it will become 1. So what it must be? If S11 is half and S12 is also half, power is half. That means if I will substitute here, it will become 1 by 4, this is also 1 by 4 and this is half. These two will become 1 by 2. So 1 by 2 is 1. So that means if my condition is this, then it will satisfy the lossless junction. All junctions are lossless in nature. So that means my S11 is half and S12 is half. If S11 is half, S11 is equals to S22, that is also half, and S12 is equals to S21, that is also half. Now if you substitute all these parameters and if you take either row wise or column wise, it must be equal to 1, because here we have considered all the junctions are, the 3-port junctions are lossless in nature. Maximum power is delivered. So using this assumption, I will substitute here in the scattering matrix. So my S parameter S11, S12, S13, S21, S22, S23, S31, S32 and S33. So already the parameters we have identified.